All right, welcome back. So we're gonna move on from these more theoretical models, kind of talking about what these different population level coefficients mean. So what beta naught, beta 1, beta 2, beta 3, we kind of saw what they mean by writing out the models for each level of our categorical variable. Now we're going to kind of translate that into interpretations of fitted coefficients. And so we're really going to be using a lot of what we already talked about to write those interpretations, but it'll probably be even more clear with some actual numbers from the table or from the summary table of output in that non-parallel lines model. And so we're actually going to skip over the hypothesis testing part. We'll come back to that later and jump to page 7, so titled Interpreting Coefficients. We will end up using the summary table on page 6, though, for this non-parallel lines model. And so we'll use these estimates for beta hat naught, beta hat 1, beta hat 2, and beta hat 3. So the estimates are just given in their usual format in the summary table of output. And so what we'll start by doing is writing out the fitted model first in its entirety and then breaking it down for each level of the wine type. So for white wine and then for red wine as well. And so the full fitted model that I'm again just grabbing from this table here is our predicted quality is just going to be this intercept minus 4.898 times chlorides plus 0.7152 times this type indicator, and then minus 14.8 times chlorides times the type indicator. So that's our interaction term since we're using this non-parallel lines model. And so it might first be a little bit more helpful to see if we made a couple of specific predictions before talking about things more generally. And so if we wanted to predict the quality of a red wine that has a chlorides level of 0.07, we've already defined this type ind now a couple times, but just so that it's on this page, remember we defined it so that it's a 1 if the wine is white, a 0 if the wine is red. What we're going to do to predict this quality of this red wine is just plug in 0.07 wherever we see chlorides, and then plug in 0 whenever we see this type indicator, because that's how it was defined before. So just like with regular multiplication, the last two terms drop out, and this is our predicted quality for the red wine. So if you do that calculation, it should come out to about 5.7. And so the quality of the white wine is going to look really similar for the same level of chlorides, except that instead of plugging in a 0, we're going to plug in a 1 for that type indicator. And so again, if you calculate all of that out, you should get a predicted white wine quality for this level of chlorides of about 5.4. So you should kind of be able to see more generally from the red wine equation that in general the fitted model is going to be the 6.42 minus 4.898 times chlorides. And so this is the fitted model for any kind of general level of chlorides. Before we had a specific 0.07 that we were plugging in, but this is the more general fitted equation for red wine quality. So the interpretation of beta naught is that it's just the intercept for red wine. So when chlorides are 0, we expect the average quality of red wine to be 6.042 points. All right, so it's got the same exact interpretation as the intercept in simple linear regression, except now we have to make it clear that we're talking about red wine. And so this isn't the intercept for white wine. Similarly, beta hat 1 is the slope. So it's more specifically the slope for the relationship between quality and chlorides in red wine. We're not going to write it out, but you could still have that same interpretation for a 1, I forget what the units are, but for a 1 unit increase in chlorides, we expect the wine quality of red wines on average to increase or decrease by beta hat 1. So we're kind of building on what we did before, and it's just a little bit more complex now that we have this categorical predictor in the model. Similarly, the fitted model for a white wine, you could pretty much do what we did before, but replace 0.07 with chlorides to make it more general. And you could end up kind of grouping the like terms, just like what we did when we were writing the population level model. And we could kind of label what each of these things were so we don't really lose track of them. So remember the 6.042 was beta hat naught, 0.71 was beta hat 2, negative 4.898 was beta hat 1, and negative 14.8 was beta hat 3. And so our interpretation of beta hat 2 and beta hat 3, these aren't the intercept and slope of white wine, because we see that the intercept for white wine is actually beta hat naught plus beta hat 2. So what this is, and we noted this before as well, is that beta hat 2 is the difference in intercepts between white and red wine. And so you could see in this particular example that white wine has a larger intercept by 0.7152. Beta hat 3 is the difference in slopes. And so we could see here that white wine has a more negative slope than red wine does by 14.8. All right, so just to kind of recap then, the fitted, when we kind of see this model output, we can now identify what each of the fitted coefficients actually are. Beta hat naught is the intercept for red wine. Beta hat 1 is the slope for red wine. Beta hat naught plus beta hat 2 is the intercept for white wine. And beta hat 1 plus beta hat 3 is the slope for white wine. All right, so if we wanted the intercept and slope for white wine, we would have to do a little bit of calculation from that summary output. And we would know that beta hat 2 and beta hat 3 represent the differences in the intercepts and the differences in the slopes between the two categories of our categorical predictor variable. Okay, so that might be kind of a lot. And so we will get a lot of chances to kind of practice with this stuff. So we'll have kind of a chance to practice this in R using some coffee ratings data. And then we'll also actually get a chance to practice this on a handout, kind of practicing writing out more of these interpretations. So hopefully this is just kind of a nice introduction, and that most of this hopefully makes sense, but if it doesn't, we will definitely be coming back to this for more practice in the next week or so.